numpys are basically also used to work with arrays, but this is sort of quite more efficient as compared to the traditional arrays which we are using in Python. NumPys are comparatively faster and they consist of a lot of methods as compared to array. That makes our job very, very easy. As you can see, we have a point written over here that NumPy arrays are about 50 times faster than traditional Python lists. So this creates a huge impact when you're working on big projects and when you're working on, for example, if you are solving problems of competitive programming. So this actually helps a lot when using NumPy arrays instead of traditional Python list or Python arrays. Now, arrays in NumPy are also called ND arrays. To use NumPy, we first need to install it. So pip install NumPy. We discuss what pip is. It is the package manager, and we can install a lot of modules and packages with the help of pip. So before using NumPy, we install it using pip install NumPy. Then we import it in our file using this particular statement. Actually, we can only use this part only, import numpy, as np is just an aliasing. That is, if we in the arrays example we saw that we had to mention array, the module name dot the method which we want to use. For example, array. So if I don't want to write the entire module name, I don't want to actually write the entire module name numpy. So what I do is import numpy as np. So we can refer to numpy just using this character, and we'll see shortly how it works. So these are the data types which are supported in NumPy. We have booleans, we have integers, we have int c. So int c is identical to the c data types, equivalent to uh, the integer. We also have int p, int 8, int 16, int 32. These are the ranges, the byte range. So int can have 8 bytes, int can range from 16 bytes, 32 bytes, 64 bytes. We can have unsigned integers, and we can have floats, we can have complex numbers as well. These are some of the NumPy methods. We can create arrays using all these methods. We also have some properties like size, shape, dtype. We can copy elements in the NumPy array. We can sort and we can reshape. What reshaping is, let's have a look at that right into the Google Colapse. So this is the import statement that we are using import numpy as np. So instead of writing entire this particular word numpy, what I do is I simply mention np, and that does the job for us. So I say np dot the method which I want to use to initialize the array, and that method is array. Now, unlike the array module which we have seen just before this, we need not mention the type code. That is not necessary to mention the type code over here, because the NumPy automatically understands that since we have all elements as integers, so we want to make use of integers only. So it will decide the type code accordingly. Now, when I say type of array, we can see it is a NumPy ND array and not a traditional array. Now we have this property which we saw in the PPT. This is the D type property. It is used to check the data type of elements in the array. By default, if we have integers, it denotes the int 64, that is a 64-byte integer. Since 64 bytes meaning the range of integers is quite long. So that by default, if we have integers, it will initialize it as int 64. So D type is used to check the data type. Now we have several other methods as well to initialize an array. For example, if I want an array of all zeros, so I have this zeros method. So what I do is np.zeros, and then mention the number of elements I want in my numpy array, nd array. So over here I want 10. So in the output I get 10 zeros. Now by default, this method assumes that you want a floating point answer, that is answers with decimal. So as you can see, we have 0 0.0 0 0.0 0 point everywhere. Now then, if I want the data type to be something else, for example, if I want it to be complex number, so what I do is I pass the second parameter as the data type which I want. So over here I have 8, which denotes the number of elements, and complex meaning the type of data which we want. So This will yield the output as 0 plus 0j and 0 plus 0j and so on. Creating a 2D array. Now, in traditional arrays which we saw, we cannot create 2D arrays or 3D arrays or 4D arrays. But in case of NumPys, yes, we can. We can create 2D arrays and 3D arrays. If you are coming from other programming languages, and you might have noticed one thing, that while practicing arrays in two-dimensional arrays and three-dimensional arrays, you used to work with matrices a lot, and even matrices are used a lot of times in many applications. But using use of matrices is not possible with traditional arrays. Similarly, we have various applications of 3D arrays as well. But we can create these arrays and cater to that problem using numpys. So I can actually create a numpy array. So have a look at this. This is a 2D list. It consists of three sublists, and each list consists of three elements. So when I print this array, 2D array, it will print the entire array. You can see we have three rows, we have three columns. The shape is 3, 3. Shape is basically the dimension of the array. So over here, as I said, we have three rows, three columns. So the dimension is going to be 3, comma 3. Similarly, we can also create a 3D array. We have three lists which consist of three lists, which in turn consist of two elements. So three list, so that is the first dimension, that is 3. Then each list consists of three more lists, so that is going to be the second dimension 3. And each such list consists of two elements, so this is the third value over here. That is the third dimension of this 3D array. So it is 3, 3, and 2. You can create an array of any dimension and any shape and whatever you want. It's just that it should be valid. No, you cannot really have a 2D array of dimension 3, comma 3, but have only 7 elements. Now that is quite understandable. So only you need to make sure that the number of elements and the dimensions are quite accepting. So this is the way to create a 3D array. Just simple. We can also create an array of constants. So let's have a look at this method. First of all, we have this empty method. So this empty method accepts an argument which is the number of empty elements which we want. So when I print array, it will print some random values which are garbage values, and it is going to print them and store it in various variables which I have used. So this will actually create an empty array with some random value. Now this method fill is basically used to fill the entire array with a certain value. Here I mentioned that value to be 6. So what it does is fills the entire array with the value 6, and we get this output. Now we have this arange method, which is used to initialize an ND array in a particular range. So when I say a range of 10, so if I mention only one argument, it starts from 0, and then it uh, goes until 10 with a gap of 1. And it will not actually include 10 over there. It stops at one position before only. So it will actually stop at 9. So it will start from 0 and go up till 9. Next, we can also specify the steps and the minimum and maximum number. So if I want to start with 10, end at 100 with a gap of 2. So if I want even numbers from 10 to 100, excluding 100. So what I do is np.arange. The first parameter is going to be the starting value. Next parameter is going to be the last value, and the next parameter is going to be the increment which I want to use. So increments can be positive, it can be negative, and accordingly you will decide the starting and the ending values as well. Next, since we saw what shapes are, shape is basically the dimensions of the array. As we have seen before, this particular 3D array has this shape of 332. Now, for example, if I want to reshape an array, yes, we can do that using this reshape method. So have a look at this point. Array before reshaping. So we have considered this same array which we have made using arange. So it consists of all the elements right from 10 to 100, which are even numbers. So this is my original array. Now I check the size. Size denotes the number of characters, number of elements which we have in the array. Since the size is 45, so it is quite understandable that one of the dimensions which we can use is 9 by 5. So we can have 9 rows and 5 columns. So that is one valid dimension which we can use. I cannot have 9 by 6 because we don't have the relevant elements. I cannot have 10 by 3 because even then we don't have the elements. So we want to make sure that when we reshape, we get a valid array. So we can do that using reshape. The first one is going to be the number of columns. The next one is going to be the number of rows. So when I do it, I get the reshaped array, and this is my output. Again, the original array remains as it was, and the only thing which changes is the is this particular array, the new one which I have used. This that is the reshaped array. Next, since we talked about matrices before, we can deal with matrices using NumPy since NumPy supports two-dimensional array. So what I do is take these two arrays and then perform some operation. So these arrays are actually acting as matrices. So this is my first matrix, this is my second matrix, and I get this output. Matrix addition, it is quite simple. All you need to do is A plus B, just like you used to do in mathematics. No complications of using loops to add each and every element. All you do is use this plus operator. Matrix multiplication, no, this is not the same. You cannot simply write the multiplication sign and it will multiply because matrix multiplication works quite differently. It is not that the first element of the first row will multiply with the first element of the first row only. So that particular thing is quite complicated in matrices. So when I use this multiplication operator, that won't yield the result which I would expect. Instead, if I actually want to perform matrix multiplication, I use the mat-mul method, which can be used to multiply two matrices. So if I say A and B and use the mat-mul method, this will give me the matrix multiplication of these two methods, these two matrices. Finally, we have another method, that is the identity method, which is used to create an identity matrix of the order which we specify. So an identity matrix of order 4 will look like this. Similarly, we can create an identity matrix of order 2, 3, 4, 5, and anything which we want. So this was just a gist of what NumPy are. Again, to have a good grasp and have, if you want to have a look at all the methods which we have in NumPy, you can definitely go to the NumPy official documentation, click on the documentation, and then you can refer all things which we have in NumPy. It has what is NumPy, and you can also go to tutorials and see what it has.